Johannes van der Waals. Johannes van der Waals was born November 23, 1837, and died on March 9, 1923, in the Netherlands. He married Anna Magdalena Smit in 1865 and had 3 daughters and 1 son. He received an elementary education in Leiden and studied at the University of Leiden in his spare time and eventually obtained mathematics and physics teaching certificates. He received his doctorate's degree in 1873. After high school, van der Waals began an apprenticeship as a teacher and became certified at age 24. Following his certification, he began teaching at secondary schools throughout the Netherlands. He was appointed the first professor of physics in 1877 at the University of Amsterdam. He remained at the university until succeeded by his son, Johannes van der Waals Jr. Van der Waals mainly investigated states of matter. His work predicated the existence of molecules and the assumption that molecules are of finite size and attract each other. His thesis, titled On the Continuity of the Gas and Liquid State, proposed a correction to the equation of state for ideal gases that would allow the equation to be applied to real gases. The modification took into account the fact that atoms are real and interact. Intrigued by physics, van der Waals investigated further into their findings and discovered the necessity of taking into account the volumes of molecules and the intermolecular forces in establishing the relationship between pressure, volume, and temperature of gases and liquids. Intermolecular forces are more commonly called van der Waals forces. His name is also associated with van der Waals molecules, which are small molecular clusters, and van der Waals radii, which are the sizes of molecules. The ability of geckos to climb on sheer surfaces has been attributed to the van der Waals forces between the surface and the projections on the footpads of these animals. The van der Waals equation is an equation of state for a fluid made of particles that have a non-zero volume and an attractive interparticle force, such as the van der Waals force. It is based on the modification of the ideal gas law and approximates the behavior of real fluids while accounting for the size and attraction of molecules. Van der Waals was also responsible for the discovery of many different laws and theories. Among them are the law of corresponding states and the thermodynamic theory of capillarity. The law of corresponding states concludes that all fluids have the same compressibility factor after scaling the temperature, pressure, and volume to their respective critical values. This law aided other scientists in their experiments. The thermodynamic theory of capillarity first appeared in 1893. This theory acknowledged the existence of a gradual yet still rapid change of density at the boundary layer between liquid and vapor. This was in contrast to other scientists, such as Gibbs, who believed that there was a sudden transition between the two stages. Van der Waals received many honors and distinctions. He received an honorary doctorate of the University of Cambridge, was made honorary member of the Imperial Society of Naturalists of Moscow, the Royal Irish Academy, and the American Philosophical Society, was made an associate member of the Royal Academy of Sciences in Belgium, and won the Nobel Prize in Physics in 1910 for his work on the equation of state for gases and liquids.